All right, you guys, we're going to continue our examples of finding the domain of composite functions. All right, so in the previous video, we did part A. Now we're going to do B. All right, so this time we're doing F composed of F. And not only do they want us to find the composite function, they also want us to find the domain. So I'm going to write it like this: F composed of F of X. All right, so this tells me everywhere in the F function, I'm going to put the F function back there for X, okay? So I'm gonna write the F function, which is 1 over X. I'm gonna put parentheses in its place, plus 2, okay? The parentheses tells me where I need to put the other function. So I'm putting F inside of F. So in this parentheses, I'm gonna put 1 over X plus 2. Okay, so at this point, I've composed each function inside of each other. All right, so I need to simplify it now. So the numerator is going to stay the same, 1 over, okay? Now I've got this fraction and I have this whole number. The only way you can combine those is if you have a common denominator. So I'm going to multiply the 2 by x plus 2 over x plus 2. Okay, so the first rational is going to stay the same. 1, change that back. 1 over x plus 2. For the second one, I'm going to distribute the 2 to both of those terms, okay, which is going to give me 2x plus 4 over x plus 2, okay. Now that their denominators are the same, I can add their numerators. So that's going to give me 1 over 1 plus 2x plus 4 over x plus 2. That's going to give me 1 over 2x plus 5 over x plus 2. Okay. Instead of dividing by a fraction, I can multiply by the reciprocal. Keep, change, flip. Okay. And then multiply across. So my composite function is x plus 2 over 2x plus 5. Okay. So I found my composite function. Now we've got to find the domain. Okay. So remember, if the filter example helps you think about it, feel free to use that. Okay. So if we're thinking about the filters, the first filter in this function would be the inside function, which is f of x this time. Okay. And the second filter is our composite function, which is f composed of f of x. Okay, so we're going to look at the types of functions that we have. So for f of x, okay, which is this function here, okay, f of x is a rational function. It looks like a fraction, so it's a rational. And we know that for rational functions, the denominator cannot equal 0 when it comes to the domain. Okay, so we need to find the values that are going to make that 0. So I'm going to take the denominator, which is x plus 2. Oops. And we're going to solve for x. So we're going to subtract 2. X equals negative 2. So that means I can plug in whatever I want into that function as long as x does not equal negative 2. So in the first filter, x cannot equal negative 2. All right. Then we go to look at the second filter, which is our composite function. Okay. It is also a rational. Okay. Because it is a rational, that means that also its denominator cannot equal 0. Okay. So we're going to say 2x plus 5 equals 0. And we're going to solve for x. So x equals negative 5 over 2. So that means we can plug in anything we want into that function as long as x does not equal negative 5 over 2. So when it comes to the domain, okay, of this composite function, all right, we can say, all right, we can include all x such that x does not equal negative 5 over 2 and negative 2. Okay. Cool. We're all set.